Hey everyone, welcome back. So I got this comment and yes, I'm here to do an explicit video on Pearson correlation. And before I proceed, I really want to appreciate everyone that has subscribed to this channel. Thank you so much for subscribing. Thank you for the likes. Thank you for watching. I'm glad you all found this video helpful. So today, I'm walking you through a complete real example of hypothesis testing using Pearson correlation in SPSS. From writing your hypothesis, to checking assumptions, to running the test, all the way to writing it up properly. I'm using a data set I put together of 60 students with variables like study hours, sleep, attendance, stress, Paris GPA, and their final exam score. So I'll drop the dataset link in the description so you can follow along with the exact same numbers I'm using. By the end of this video, you will know exactly how to go from a research question to a properly reported statistical result. Let's get into it, guys. So here's our research question. Is there a relationship between how many hours a student studies per week and their final exam score? Let's translate that into formal hypothesis. I hope you all know that there are two types of hypotheses. We have the null hypothesis and the alternative hypothesis. The null hypothesis states that there is no significant linear relationship between study hours and exam scores in the population. In symbol, the p-value equals to 0. So the alternative hypothesis states that there is a significant linear relationship between study hours and exam scores. And in symbols, this means that the p-value is not equals to 0. This is a two-stage hypothesis because we are not predicting a direction ahead of time. We are just asking, is there a relationship at all? If we specifically predicted more study hours will increase scores, that would be a one-tailed directional hypothesis instead. Like I said earlier, I've got 60 students, each with study hours, the average hours studied per week, the sleep hours, the average hours of sleep per night, the attendance, which is the percentage of classes attended, the stress level, which is the self-reported stress from 1 to 10, the prior GPA, which is the GPA before this course, exam score, which is the final score out of 100. I know some people will be like, why don't you just go straight to the point? Analysis is not something you just jump on, input your data into SPSS and start analyzing. Trust me, if you don't understand all the basics, understand how to see your research objective, what to look out for, trust me, even when SPSS analyzes it for you, when it's time to interpret, it is well. Today we are focused on study hours and exam scores. So this dataset has a couple of missing values and all because real data is never perfectly clean. So I want to show you how SPSS handles that. For running the actual test, we need to check that Pearson correlation is even appropriate here. And these are 4 things to check. The first thing to check is to ensure that both variables are continuous data. And as you can see, both the study hours and the exam scores are continuous data, which is good. So you can proceed to the next assumption. The second assumption is to ensure that the relationship between both variables are roughly linear. Third assumption is to ensure that there are no major outliers distorting the picture, which is distorting the variable. The last assumption, variables should be roughly normally distributed. So we are going to check some of the assumptions. Right now, let's check linearity and outliers with a scatter plot. Go to graphs, under legacy dialogues, click on scatter, then click on simple scatter and divine. Put the exam score on the y-axis and the study hours on the x-axis and click OK. Look at that, a clear upward trend. So as study hours go up, exam scores tend to go up too. That satisfies linearity. So that already clears the assumption number 2. Now look closely near the bottom left. See this one point. That's student number 60. They only studied 2 hours a week but still scored an 88. That's mild outlier. Worth noting, but not extreme enough to throw out because you can see it's still within the 100 exam score. If this happens in your own type of analysis, don't just delete it. Ensure that you mention this in your write-up. Assuming the score is 120, we know that for the highest exam score a student can have is 100. So if you are saying 120, 150, so you know that that is an error. So that is when you either delete or you document it. Do you understand? Now for formality, this is how you run it. Click on Analyze, click on Descriptive Statistics and click on Explore. Put the exam score and the study hours in the dependent list. So for today, as you can see on the screen, both variables are close enough to normal for us to proceed. Yes, so one more thing before we run the test. If you scroll through the data set, you will notice 2 blank cells. So what if this data is actually too much that you cannot identify all the blank cells? So you can see one in the sleep hours and one in the attendance. That's completely normal in real research, and not every participant answers every question. So since we are only correlating the study hours and the exam scores today, and neither of those columns have missing data, it won't affect our results. So, but note, if the column you are using have missing value, it's going to affect, and here is why. By default, SPSS Bivariate correlate procedure using pairwise exclusion, meaning that it only drops a case from a specific correlation if that pair has missing data, not the whole data set. Let's say, for instance, now you know the 2 variables we are using, there is no missing data there. So let's say you are doing the analysis of all of the data sets and some of the columns have missing data while some do not have missing data. So while it is doing the correlation for some pair that don't have missing data, it will do for the complete student data set. Do you understand? But for the columns that have missing data, it will extract or leave out the the missing data. So this is what pairwise exclusion is. It is different from the listwise. The listwise will remove the student information completely. Now let's run the actual test. Go to Analyze, click on Correlate and click on Bivariate. You might be wondering, why did we click on Bivariate and not partial? We are using Bivariate specifically because Pearson correlation by definition looks at how 2 variables move together, in our case study hours and exam score. So you use bivariate when you are looking at relationship between 2 continuous variables. I'll do for only the 2 variables I'm working with and also carry out the Pearson correlation for all of the variables, so you guys clearly understand what I'm saying. You use partial when you want to check the relationship between 2 variables while statistically controlling for a 3rd variable. So let's say, for example, what you are looking at is what is the relationship between study hours and exam scores while you are controlling for prior GPA. So you use the distances for more specialized similarity or dissimilarity calculations, and this is mostly used in cluster analysis, not just typical hypothesis testing. So you might the most common one are either bivariate or partial, and I think you already understand why we are using bivariate in this example. So now move your study hours and exam score into the variable box on the right. Under correlation coefficients, Pearson should already be checked, just as you can see here. And under the test of significance, select 2-tailed, which is matching our non-directional hypothesis, as you can see. So leave this option checked, then click on OK. Here in this output, only 3 numbers matter to us. The first one, which is the Pearson correlation, and you can see there that we have 0.62 value. That's a positive moderately strong correlation, and this is based on the general guide. The general guide states that if you have a value between 0.10 to 0.29, that is a weak correlation. If you have between 0.30 to 0.49, that is a moderate correlation, and if you have between 0.50 and above, that is a strong correlation. And also you can see that it is a positive value. We do not have a negative value there, hence why we have a positive moderately strong correlation. So you can see students who study more hours per week really do tend to score meaningfully higher on the exam score, at least in this sample. So the second value we are looking at is the significance, which is 2-tailed, and the result is less than 0.001. If you've copied or exported your output into Word documents, it will show you as 0.000. So I always prefer to make that correction whenever I copy, just to be conscious of that. So when you see 0.000 in your SPSS output, know that it is not 0. It's better to just impute less than 0.001. The third value we are looking at is the number. You can see that the number here is 60, and that confirms that all 60 students were included in this particular correlation. Now we apply our decision rule. Is P less than 0.05? Yes, just as you can see, and so we reject the null hypothesis, and the conclusion is that there is a statistically significant positive relationship between the study hours and exam scores in this sample. So now that we have our output, this is how you report it, because I noticed that even beyond knowing what your interpretation means, rightly and correctly reporting it either in your thesis or in whatsoever you are doing, full sentence form when interpreting, this is how it is. Using APS style in case you are using a different style. A Pearson correlation was conducted to examine the relationship between weekly study hours and final exam scores among 60 students. There was a statistically significant, strong positive correlation between the two variables. You can see I repeat it. First of all, it is statistically significant. Then it is strong and positive. Then you write out the value here. As you can see, this is the accepted value for APA style, indicating that students who studied more hours per week tend to achieve higher exam scores. So yeah, we are done with Pearson correlation, but I said it earlier that I will want to show you the full correlation matrix of the entire data set. So if you still like to see how that is done, stick around. So you go back to analyze, click on correlate, remember bivariate, but this time add all the numeric values, click OK, and SPSS gives you a full correlation matrix, just as you can see here on the screen, every variable against every other variable in one table, just as you can see it here. So a couple of interesting patterns that jumps out is that attendance also fairly correlates strongly with exam score, just as you can see around 0.56, while sleep hours barely correlates with exam score at all, around 0.06. Practically there's no relationship, and stress level shows a negative relationship with sleep hours around minus 0.40, so which makes intuitive sense, right? Because less sleep, more stress right here. So this is a great way to explore several relationships at once. 3 quick reminders before we wrap this up. The first one is correlation is not causation. The second reminder is that don't report SPSS as 0.00 literally. Always write it as p value less than 0.001. Then the third reminder is always check your scatter plot first. If we had skipped that step, we wouldn't have caught our one outlier or even confirmed the relationship was actually linear before trusting the R value. So that is a complete walkthrough to Pearson correlation. If you have any question, don't forget to ask in the comment section, and definitely I will give you the right answers. And also the data set is linked in the description. If you want to practice this yourself, try running the same test with attendance instead of sleep hours and see what you get. Interpret it on your own. That is one way to know that you actually understood what you just left right now. So don't forget to subscribe if you've not, like, and turn on the notification buttons for upcoming videos. I'll see you in the next video. Take care of yourself, you guys. Bye.